In this lesson, we're going to talk about types of numbers, which you probably talked about at some point in some previous classes. There's one type that you maybe have not heard of yet, which is actually the biggest whole type. Every single number, numbers that you know of and numbers that you don't know of, every number is a complex number. So in that big outside rectangle, the biggest one here, complex, which we are not going to talk about a whole lot in this lesson, but we are going to, in Unit 3, focus completely on complex numbers. Now, most of the numbers, if not all of the numbers you know, are called real numbers. That is that next rectangle box are real numbers. So because that rectangle of real is inside the complex rectangle, that means every single real number is also a complex number. Now, we're not going to talk about too much in this lesson. We are going to talk about it in Unit 3. Inside the complex, there's not a little place for it, but if a number is not real, if it's not real, then you can make yourself a little circle here. They're actually called imaginary. And no, I am not making that up. If a number is not real, it is imaginary, which we will talk about in Unit 3 of what that means. So if a number is not real, it is imaginary. And both real and imaginary numbers are complex because every number is complex. But we're going to focus on real numbers and those different subgroups. So inside the real rectangle, you have all those little circles. You have first this big circle. These are your rational numbers. Now, on the rationals, I wrote any fraction. That does not mean that rationals are only fractions, but what it means is that rational numbers can be written as a fraction. It can be converted from a decimal form to a fraction form, or numbers like 7 is a fraction because that is 7 over 1. So if it is a decimal that ends like 0.5, I could convert that to a fraction. That's 1/2. If it's a decimal that repeats, it also could be written as a fraction. Great example is 0.33333333 repeating. That's 1/3. But even decimals like 0.25252525 and it's repeating that can be converted into a fraction, which then makes it a rational number. Now, every single real number is either rational or, in the circle not attached to that one, is irrational. And the big difference between rational and irrational is irrational cannot be written as a fraction. So those are going to be your decimals that never end and never repeat. Great example, pi. But there are lots of other good examples. A lot of your square roots or your other roots, cube roots, fourth roots, whatever, if you can't take the root of a number, then that is going to be an irrational number. For example, the square root of 2. You can't take the square root of 2 when you type it in a calculator. It doesn't simplify down to one exact number. Square root of 2 is going to be irrational. It's a decimal that doesn't end, doesn't repeat. It cannot be turned into a fraction. Now, let's talk about the rational numbers. The rational numbers, some of them can then be considered integers also. Integers are all of your positive and negative whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, and -1, -2, -3, -4, so on and so forth. So integers have no decimals or fractions, but they're positive or negative. Now, integers are within the rational circle, so that means every integer is also a rational number. So if I give you a number like -7, you're going to tell me that's an integer, but it's also a rational number because it's in that circle. But that circle is also in the real box. So -7 is an integer, it is rational, and it is real. And the real is in the complex rectangle. So -7 is an integer, it is rational, it is real, and it is complex. And that's going to be true of every integer. Every integer is also a rational, a real, and a complex number. It is not irrational because that circle is not attached, and it is not imaginary because if it's real, it's not imaginary. Inside the integers, a smaller section, are your whole numbers. Those are your 0, 1, 2, 3, so on and so forth, just the positive numbers that do not have decimals. Whole numbers are within the integers, within the rationals, within the reals, within the complex. So all whole numbers are whole, integer, rational, real, and complex. They are not irrational because you can't be both rational and irrational. And they're not imaginary because you can't be both real and imaginary. And your last circle are your natural. And what's the difference between whole and natural? Naturals don't have 0. So the only difference between natural and whole is whole has the number 0, naturals don't. And an easy way to remember that, if you count naturally, you're going to count 1, 2, 3, 4. That's how we count. We don't count 0, 1, 2, 3, 4. Right? When I say start counting the people in this room, you're going to start with the number 1 naturally. So the natural numbers have 1, or start with 1. The whole numbers start with 0. Every natural number is a whole, is an integer, is a rational, is a real, is a complex. Every irrational number is irrational, real, and complex. That's how this diagram works. So determine if the following statements are true or false. All integers are whole numbers. Go back to your diagram. Looking at your integers, if we're in the integer column or circle, are all of those going to be whole numbers also? No. If you started a bigger one, you don't go down, you go out. So integers can be whole numbers because a whole number is an integer, but an integer is not necessarily a whole number. For example, -7 is not a whole number. It is an integer. But +7 is an integer and is a whole number. So all integers are whole numbers? False. All whole numbers are integers. If you're in the whole number circle, that is within the integers. So yes, all whole numbers are integers. Whatever circle you start in, or rectangle, you work your way out. You cannot work your way in. Rational numbers can be written as fractions. Well, that's what I actually told you in irrationals, is they are any fraction. So rational numbers can be written as a fraction. True. Those would be your ending or your repeating decimals. If you have a calculator and you have a decimal that's ending or repeating, or any decimal, and you want to see if it can be turned to a fraction, I can show you how that can happen. I'll show you those buttons. An irrational number can be written as a fraction. That is false. That is the difference between a rational and an irrational. Rationals are fractions or can be fractions. Irrationals are not. A natural number must be rational. Well, here are your naturals. They are inside the rational circle, so that is true. A whole number can be irrational. That's false. Your whole numbers, right here, they are inside the rational circle, but not inside the irrational circle. An irrational number can be an integer. False. Similarly, you have your irrationals over here. They are completely separate from your integers. And all numbers are real numbers. False. Here's our real. Some numbers are imaginary instead. So not all numbers are real numbers because some numbers are imaginary numbers. Classifying the following, stating all of the categories they belong to, you're going to want to start with first seeing if that number can be simplified. And then you're going to want to figure out what is the innermost circle or rectangle they belong to and work your way out. So 3 cannot be simplified. 3 is just 3. 3 is a natural number, which then means it is whole, integer, rational, real, complex. Starting on the innermost and working your way out. 5.6, which is the most simplified it can be. 5.6 is a decimal. You can convert that to a fraction. If you want to see how to do that on your calculator, let me know. 5.6 also is an ending decimal. So that lets you know that because it has a decimal, it's either rational or real. In this case, rational or irrational. It's either rational or irrational. It is rational since it ends. And then because it's rational, it is real and complex. Square root of 7. Type that in your calculator. Square root of 7. When you do, you get 2.64575, blah, blah, blah. That does not end or repeat. It cannot be turned into a fraction. That is irrational. Still real and still complex. Square root of 36. Well, that's 6. So because it's 6, it is a natural, whole, integer, rational, real, and complex. And your last one, negative 42 over 3, which is the same as negative 42 divided by 3, which is negative 14. And because it's a negative number, it is not natural or whole, but it is an integer, which means it's rational, which means it is real, which means it is complex. And that is the end.